Hi everyone, Mrs. Below here. In this video, I'm going to be going over ionic nomenclature, which is also known as naming ionic compounds. So when we were naming covalent compounds, we were using the prefixes like this. Ionic compounds are not going to use these prefixes at all. So if we have a formula like this without the prefix, or we have a name like this, without the formula, if we have a name like this without the prefixes, how do we find the formula? There we go. So what you're going to do is you're going to write the two elements. We have magnesium, which is Mg, and bromide originally is bromine, which is Br on the periodic table. Next, you're going to put the charges on these, which on your periodic table, remember they are written at the top of each column that element is in. So Mg has a charge of +2 and Br has a charge of -1. Now I'm going to show you the shortcut method that I use to find the formula, and it's what I call the crisscross method. So the number here is going to become the subscript for the other element. Now with a 1, we don't write the 1s because that would be kind of silly and time consuming. So we would just leave this as Mg. We don't write the 1, you don't need to do that. And then we have Br, which will have a 2 here. Again, I don't really care about the charge necessarily. I just care about the number. Now, that's a shortcut method. As far as the why behind this, we want this overall compound to have a charge of 0. So if you have Mg, magnesium, and that has a charge of +2, you would need two bromines to balance out the +2 charge. So this would be +2, and you have two -1s. So overall, that would cancel each other out to give you an overall charge of 0. So there's one Mg and there's two Brs. That's kind of the why behind the formula. But I use the crisscross method just because it's a quick and easy, fast method to find the formula. Next, we have barium sulfide. So barium on your periodic table is Ba. Sulfide, that would originally be sulfur, which is S. And again, you're going to look at the column that they're in to find their charge. So Ba would have a charge of +2. And S would have a charge of -2. Now with these, you would end up getting, we do the crisscross, Ba2S2. Now if this happens, you do want to make sure you simplify if possible. So instead of Ba2S2, that's the same thing as saying just Bas. So if you ever have a situation where both these are the same, like a +2 and a -2, or a +1 and a -1, or a +3 and a -3, then you're going to end up getting just one of each element, which makes sense because if Ba has a charge of +2 and S has a charge of -2, you just need one of each so they would cancel out and have that overall charge of 0. And we want to simplify this if possible. Last, we have aluminum oxide. Aluminum has a charge of +3 on your periodic table. Oxide, that would be oxygen on your periodic table, and that has a charge of -2. We're going to do our crisscross. Again, the number becomes the subscript. So we would have Al2O3 would be our final answer. And that does make sense because if aluminum has a charge of +3, in order for these to cancel out with each other, okay, to get them to a point where they could cancel out. You would need 2 of these, which would give you a charge of +6, and then 3 of these, which would give you a charge of -6. And overall, those would then cancel out with each other. This would be overall +6, and this would be an overall -6, thus canceling each other out. But again, the crisscross, it's just an easier method to find the formula faster. All right, what if you see something, we'll get back to that slide in a second, something like this. It looks kind of funny. It's like sulfite. It's not sulfide. Carbonate. It's not carbide. Hydroxide looks like a hydrogen and oxygen mixed together. If you see something like that, you want to look on the back of your periodic table, which has the polyatomic ions. So on the back of your periodic table, make sure you have that. You have the polyatomic ions. So we're going to do kind of the same thing that we were doing before. I'm actually going to start with, we'll start with this one. So lithium has a charge of +1. And then sulfite, this is on the back of your periodic table. And if you find sulfite, it is SO3, and it has a charge, it says 2-, but we're gonna write as -2, that's fine, that's the same thing. And we're still going to do the crisscross method, okay? Now for this one, we have Li2, and with the SO3, so if you have a number that's going here that's not 1, you would want to put parentheses around it. However, because we just have a 1 here and we don't write the 1, we're not going to need parentheses. You just have 1 SO3. And then number 2 here is very similar to number 2 up here, where we are going to simplify. So we have calcium, which has a charge of +2, and then carbonate, that is on the back of your periodic table, which is CO3 -2. Now, if we did our crisscross method, 2, we would have Ca2. Now, if you have, again, something like this and you have a number that's not a 1, you want to put the polyatomic ion in parentheses. You're not going to like add these or anything. You want that 2 to apply to the entire polyatomic ion. However, we can simplify this though, right? Like we did up here. We can simplify this to just CaCO3, okay? Because we have a 2 and a 2, we have the same charges, so we would just simplify it to this. And then lastly, we have magnesium hydroxide. So Mg has a charge of +2. And then hydroxide, that kind of looks like a mix of like hydrogen and oxygen, which it is. On the back of your periodic table, hydroxide, it's OH, and it just has a minus like this. I didn't put the 1s in there. It does have a charge of -1. I know it's shown like this, but this and this mean the same thing. Again, we're going to do the crisscross method. So Mg, it has a 1, but we're not going to write that. And then the OH has a 2. Now, it's really important that you put the parentheses around the OH and you put the 2 on the outside. That's because this 2 then, it's getting applied to this entire thing, which is the hydroxide, the OH. If you just wrote it like this, that's only saying the 2 is just getting applied to the H, which is not what we want. So make sure if you have a number that's not like a 1, like anything other than 1, you need to have the parentheses. And then lastly, we're going to go backwards. So we're gonna be given the formula and we're gonna write the name, which is actually probably the easiest naming. It's just like what you did with the covalent stuff here, but you don't have the prefixes. So for example, Li3N, that would just be Li is lithium, and then N is nitrogen, and we change that to nitride. Okay, we change it to end in ide. NaCl. Na is sodium on the periodic table. Cl, that is chlorine, and we're going to change that to chloride. Magnesium is Mg. Hold on, magnesium. And then F on the periodic table, that is fluorine, and we're going to change that to fluoride. Okay. And that's how you name ionic compounds. Remember, covalent was just like this, but you were using the prefixes, like mono, di, tri, tetra, etc. And then what if you see something like this, where you have multiple elements going on? When you start seeing something like that, be sure to look on the back of your periodic table. So let's start with the first one. Na, again, is sodium. And then you would just look for this on the back of your periodic table. NO2 on the back of the periodic table. If you look on the back of your periodic table, it is nitrite. So this would be sodium nitrite. Next, we have Be, which is beryllium, on your periodic table. Now, it's really important when you're looking at this, look at what's inside of the parentheses, okay? Look what's inside the parentheses, because on the back of your periodic table, ClO2 is chlorite. But what you want to notice, the 2 is on the outside. So this is not beryllium chlorite. Rather, this is beryllium hypochlorite. Because you want to pay attention to what is inside of the parentheses, which is ClO. And on the back of your periodic table, that is hypochlorite. And for this last one here, we have K, which is potassium. And then we have PO4, which on the back of your periodic table, PO4 is phosphate. Okay? And that is naming ionic compounds.